When an astronaut returns from orbit, their body has endured radiation, muscle atrophy, and bone density loss. But they also experience a physical change that has nothing to do with biology. The person stepping out of that capsule is quite literally a tiny fraction of a second younger than they would have been if they had never left the ground. NASA's twin study provides a perfect baseline to see this effect. Scott Kelly spent nearly a full year living in space. Meanwhile, his identical twin brother, Mark Kelly, remained firmly on Earth. Over those 340 days, the physical mechanics of the universe caused Scott to age slightly slower than his twin. Time travel into the future is a proven, measurable consequence of spaceflight. To understand why, we have to look at the International Space Station itself. It travels at a blistering 17,500 miles per hour relative to the surface of the planet. Over a century ago, Albert Einstein laid out the mechanics for how a speed like that interacts with time. His theory of special relativity established a clear rule. As an object moves faster, the passage of time for that object actually slows down relative to an observer standing still. Because the crew aboard the ISS is moving at such an extreme velocity, the physics of their environment actively shaves microseconds off their actual age. But speed is only half the equation. There is a second competing force pulling on the clocks in space, the Earth's gravity. Under general relativity, altitude alters the math. As you move further away from the center of a massive body like Earth, the grip of gravity weakens, and as gravity weakens, time passes faster. The space station is caught in a constant tug-of-war. Its extreme velocity slows time down, while its altitude speeds it up. Operating in low Earth orbit, the time-slowing effect of its speed easily overpowers the time-speeding effect of altitude. The net mathematical result of that orbital imbalance is a slower clock. That is exactly why returning astronauts are younger. If we push further out into space, that balance shifts entirely. Consider the GPS system. Operating in medium Earth orbit, 12,000 miles up, they travel much slower than the ISS and experience significantly less gravity. At this distance, the tug-of-war flips. The time-speeding effect of altitude dwarfs the time-slowing effect of their speed. As a result, the onboard atomic clocks navigating these satellites physically tick faster than identical clocks sitting on the surface of the Earth. Engineers actually have to program the GPS network to continuously correct for this relativistic shift. If they didn't, the navigation systems on our phones would quickly lose sync with the physical world, accumulating miles of error within a single day. Einstein's theories represent literal mathematical bugs in our reality, deviations that must be solved daily to keep global infrastructure from failing. You don't actually need to go to space to observe these physical forces. Down on the Earth's surface, researchers at the National Institute of Standards and Technology measure time on a microscopic scale. Using optical aluminum atomic clocks, some of the most precise timekeeping instruments ever constructed, they can isolate the behavior of individual atoms. This technical chart from their 2010 study plots time dilation against physical velocity. Their measurements proved that the time-slowing effect of speed kicks in at everyday velocities, as low as 20 miles per hour. And in this second experiment illustrated here, researchers demonstrated the effect of altitude. A difference in height of just 33 centimeters was enough to make the higher clock tick slightly faster. The exact same physics that affect an astronaut traveling 17,000 miles per hour can be measured right here, by moving a clock 1 foot off the ground. These forces are constantly acting on all of us. Every time you walk up a flight of stairs, you are actively weakening gravity's hold on your body, causing you to age slightly faster. And every time you drive your car down the highway, you are increasing your physical velocity, causing you to age slightly slower. Time exists as a flexible local fabric, a physical medium that stretches and compresses with every movement we make.